Section 4.7 deals with triangles and coordinate proof. Now, coordinate proof is a new style of proof that uses the connection between algebra and geometry to make statements and to prove statements about geometric figures on the coordinate plane. You want to make sure you put this in your notes. Now, our goals with coordinate proof. First, coordinate proof uses figures in the coordinate plane along with algebra to prove geometric concepts. And so the first step that we need to accomplish is placing this figure properly in a coordinate plane. So let's work through a couple of examples. First, let's say we have an example. We need to place right triangle MTV, which has leg units of 2 and 5, and the hypotenuse is MV. So in a coordinate plane, we know we've got one leg that's 5 units long. We have another leg that's 2 units long. And we're going to put it kind of in the corner there. We're going to put it at, kind of centered at the origin. The reason we're doing that is we guarantee that we've got a right angle that connects the two legs. Then we're going to connect the hypotenuse and label the different points. We know point T is not on the hypotenuse, so T is at 0, 0, and then we have M at 0, 5, and V at 2, 0. Let's try another example. Let's say we want to place isosceles triangle JFK with the base JF, and that base is 10 units long, and the height of the triangle is 7 units. I'm going to show you two different ways to place this triangle. One way is to place it over the y-axis, kind of using the y-axis as a line of symmetry. And so the base is going to be 10 units long, 5 units on the positive side and 5 units on the negative side. The height, since we have a symmetrical triangle, an isosceles triangle, the height is going to be directly up from the origin. We have a height of 7, and so all we need to do is connect J and F to that point K at 0, 7 to make our isosceles triangle. That's one way to place this triangle. Another would be to put one of the corners, one of the vertices in the origin. So for example, if we put J at 0, 0, that means F would have to be at 10, 0. And point K is at 5, 7. The reason K is at 5 for its x value is it's half the length of the base. So when placing a figure on the coordinate plane, a couple of things to remember. First, place aside one side of the figure on either the x or y axis, if that's possible. Next, sometimes it makes sense to put the figure in the first quadrant. The benefit of this is it keeps the ordered pairs positive. Sometimes that's not a good idea, and sometimes we want to use one of the axes for lines of symmetry, either the x-axis or the y-axis. And lastly, it's nice to center the figure around the origin, the point 0, 0. So let's try a couple of examples. Why can't we use this figure for a coordinate proof? We've placed it well. We've got the right triangle with its right angle in the corner of the axes. The reason why is not all triangles have legs 2 units and 5 units long. And so instead of 2 and 5, we'll replace 2 and 5 with variables. So instead of 2, we'll use a letter. Instead of 5, we'll use a letter to represent all possible values. So we'll burn this up, and instead we'll use kind of a blank set of axes, and we'll put V at the point A, 0, M at the point 0, B, where A and B could be all possible numbers. Let's practice with that a little bit. So some tips. When you're placing a figure on the coordinate plane, it's good to avoid these letters X, Y, L, O, S, T, and I, because they're occasionally confused for other letters. Also, don't duplicate any letters. Don't have repeated letters unless you know for sure that there is some congruencies in the shape. And then lastly, use your calculations to make your use your coordinates to make calculations as simple as possible. We'll work through a couple of examples like that in just a bit. So here's an example. Find the missing coordinates. I've placed an isosceles triangle, ABC, over the x and y axis. And the only information here is that we have C is at A0. And so what that tells me is that point A indicates that this length is A units. Because it's an isosceles triangle, I know this length is also A units. And so the coordinates for B should be negative A, 0. Next, for the height, I don't know how tall this triangle is. It could be A units tall, but it doesn't have to be. And so now we have to pick a new variable, and I'll just choose B to be the height for point A. So A is at 0B. Pause the video and try this next example on your own. We see that point E is at negative B0. So negative B indicates that this length is B units long. And so for point F, the x-coordinate must also be B. Must also be negative B. And now the height, or the vertical distance for point F, we see we've got these congruence marks, one along segment ED and the other along segment EF. And that indicates to me that this length is also B units tall. And so the coordinates for point F should be negative B in the x direction and B in the y direction. And one last example. Pause the video and give this a try on your own. For point H, we see we've got A plus 2 units in the x direction, and so we're going to move the same distance but in the negative x direction. So for point G, you could have negative A minus 2, comma, 0. Another option could be negative quantity A plus 2, comma, 0. Either of those would be legitimate coordinates for point G. Now for point I, we're not sure of how tall this isosceles triangle is, and so we're just going to pick 0B, because that distance could be any possible values here. Oop, there we go. Lastly, one example. If I need to place and label a scalene triangle, we're going to call it NBC. In this case, we've got a number of different variables to place. Give it a try. See if you can sketch out a scalene triangle with one side on one of the axes, one of the points at the origin, and a minimum number of letters to indicate that we do have indeed a scalene triangle. Here's one possibility. I put one of the side lengths on the x-axis, one of the points is at the origin, point N, and then each of the other points, point B and point C, have unique values for their x and y coordinates. B is at A0 and point C is at BC. Next, I'd like to show you a video of how to place these using GeoGebra. I wanted to show you how to verify coordinate placings using GeoGebra. Let's take, for example, the triangle MTV from the previous. We had a right triangle called MTV. MV was the hypotenuse. T was at 0, 0. And so we can place T right away. Then we had two variables. We had A and B. So in the input bar down here, we're going to just say A equals, and then we're just going to pick some number for now. We can change that number up. we're going to say b equals some other number, and again we can change that value. Now point M was a point on the hypotenuse, and I believe we had put that point as the y-intercept. And so its coordinates will be 0, b. And you can see we've got the point 0, 2 because b is identified with number 2. And then we had point V, which was A, 0. So now I see I've got A, B, and C. We'll just use the polygon tool to connect M, T, V, and then back to M. So we've got our polygon. Now with these two numbers, you can see right now the little dots next to them are not highlighted. So using the move tool, just fill in those dots. And you can see now we've got sliders for each of those variables, point A and point B. And so if I move around A, you can see whatever value of A, I still maintain a right triangle. And likewise, if I move around B, I still maintain a right triangle. In fact, one other thing we can do, just to sort of visualize this more easily, we can actually select one of the sliders and then go to Object Properties, and we can see we want to turn animation on. We can actually do this for both of these numbers. So I'm just going to select number at the top here. I'm going to turn animation on. And you can see it doesn't matter what value of A and B. Every value of A and B produces a right triangle. So it's just kind of another way to validate or to verify that this algebraic proof, this coordinate proof, will always hold true for any values of A and B.